Hey everybody. Today we are going to talk about the difference between rasterized and vector images. When we paint on a real surface, it looks like real paint, it reacts like real paint, because guess what? It is real paint. But when we're painting digitally, what's actually happening is that the computer is interpreting hundreds of different pressure points in our pen and speed and reference in the actual pad to determine where our pen is. And when we push harder, it makes the color darker, lighter makes the color lighter, moving slowly makes less paint come out, moving quickly can make more paint come out. It all depends on what that particular brush variant is set to do. The painter is doing some heavy duty calculations for every time we move our brush on screen. However, there isn't really paints in the computer. And all of that interpretation is just a way for Painter to interpret what we're saying when we move our pen along the tablet. So when we make a brush variant that's a different item, we're just telling Painter to interpret our stroke, most of the time the same kind of stroke, in a completely different way. So we're giving it the same information and asking it to do different results. And it's creating those different results through a long, complicated process. But how it displays it, there are really only two ways that a computer can display digital images, and that's raster and vector. A rasterized image is one that we're used to seeing pixelated. And the definition of raster is a rectangular pattern of parallel scanning lines followed by the electronic beam on a television screen or computer monitor. So what that means is that it's the way that television screens and computer screens project pictures is they project a single color in a square that is a pixel for the entirety of a screen, right? So each and every square that exists on a screen is basically assigned a color, and it's told you will be this color, and it is set to remember that color, and that is how a file is saved. So if this were an actual picture, each square would be a pixel. So this would be 4 pixels high by 6 pixels wide. And if we were to make a picture in this 4 by 6 range, we wouldn't be able to tell it, hey, make this one half purple and half white. We can't do that. What we can do is we can tell them, hey, make this whole thing purple, make this one purple, make this one purple, and make this one purple. Well, it kind of looks like a diagonal line, but the idea is the farther away you get, the smoother that looks. And if you don't think that's true, when I zoom in real close to this definition, you can see that this definition is a rasterized image. And I took the text feature that you can normally see in Painter, and I went ahead and turned it into a raster image. Right here you can see that this has a little T on it, and this does not. And that means this is no longer a vector image. It's no longer editable, and it is now a rasterized image. You can see that all of the background pixels are being told that they're white. And when you get close to an item, they're being told they're 10% purple, 20% purple, 80% purple, 90% purple, or 100% purple. You can see here that this is probably 10, 50, 80, and 100% purple. And these definitions of every one of these tiny little squares is telling the file how to do this. And you can see up here where I used an actual brush stroke that this is exactly the same. the computer is making all sorts of calculations to specifically tell Painter how to interpret our input into pixels on the screen. But what it's doing is it's putting pixels on the screen. If you were to open Painter, Paint, not Painter, but plain old Microsoft Paint, and paint with its paintbrush, all it's actually doing is painting with one single itty bitty pixel on a brush, on the end of a brush. And if we take ours and move it down to 1, it's pretty close to that. It's pretty close to one individual pixel drawing in space. It still responds to pressure, so lighter pressure gets a lighter color and harder pressure gets a harder color, but essentially it's drawing a very straight individual line as best it can with a little bit of fade on either side. When we're talking about actual rasterized letters, you get a little bit of that extra on each side. But essentially, you're looking at a pixel by pixel play of what every single pixel in this image is doing. So when this saves, it will save as white, 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 purple, white, white, next row, white, white, purple, white, 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 purple, white, 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 purple, white. You get the picture. So it will do that for every rasterized picture in existence. So for this file, it's 9 megabytes wide, it's 9 megabytes large, because it's going for 1800 pixels wide and 1200 pixels high. And every inch of space has 300 pixels in it. So this is a lot of information. So your file size is going to be a lot bigger when it's rasterized. Most of your brushes in Painter are rasterized images. So they're going to be fuzzy around the edges. That's why we want to keep our resolution high, so that we're painting in a way that we see our brush strokes as brush strokes and not as pixels. We don't want to see them as little pixelized lines. We want to see them for the brush stroke that's in that very complicated engine that Painter has. Now, in addition to rasterized images, there is also vector images. And vector images, the word vector in math and physics is usually defined as a direction and a magnitude. And it's used for determining position and points in space that are relative to each other. We're not talking about the organism, the tick that transmits disease. We're not talking about that one at all. And another way of thinking about it is a verb, which means to direct an aircraft in flight to a desired point. So when you're flying in a plane and you call the tower and say, I need a vector, they're going to give you a very specific direction and speed in order to get where you're going. They're going to give you instructions. They're not going to draw your path for you. They're going to tell you, I want you to go from this point to this point, and I want you to slow down here and here and here, right? And it's very similar to the idea of the mathematical idea of this word, or meaning of this word. It is determining the position in a point in space, and it is giving you a direction and a magnitude. So it's saying, hey, I want you to start here, and I want you to go to here, and I want you to do it in this way, and I want you to do it light at first and dark later. Now, it does sound like what I'm telling you is this is the way Painter works, but it's not. I'm giving you a raster example of a vector idea because I can draw it. What we're actually looking at is that a vector is these tools down here, these pen tools. They exist in Painter, but we don't generally paint with them because they're much more complicated. So just like we did with our text, a vector image is anything that is not created by a brushstroke, but is instead created by a set of instructions that is telling painter how and when to accomplish something. And that seems a little bit complicated, but the result is that instead of having a rasterized image that loses quality when you zoom in on it, this text and this line will not lose quality. Now you see that there's a little bit of pixelization there, but you see how that cuts through a pixel. Part of that is because at some point this image is still 300 dpi and eventually it will have to be turned into a rasterized image. But as long as I have a vector at my beck and call, instead of just putting it down and having to erase it, I can actually pick it back up and move these handles and change the shape of a thing that already exists. Obviously you can't do that with a brush stroke. I can't do that with the stroke. I can't decide to pick it back up. I cannot click on it and change it. It is a rasterized image. When I stroked it, all it told the computer was that I wanted those pixels to change at that color at that time. But a vector remains editable, which is sometimes extremely useful and sometimes doesn't really matter. This also means that if I were to go to Canvas and resize and increase the DPI of this image, let's say to 600 DPI, right up here, this is going to get fuzzier faster than it did before. It doesn't take much zooming in to reduce the quality on these lines because they were made at 300 DPI when the pixels were much closer together. And when it was made again, the pixels were farther apart when it was duplicated. I haven't changed my brush since then, and as you can see, my brush is much smaller because my brush is a certain amount of pixels wide. So if I stroke this brush, it's going to be thinner in size because my actual file is much bigger. But my rasterized image won't change at all. It can be blown up and shrunk as many times as it likes because it doesn't depend on how many. If the number of pixels in a grouping expands, it doesn't change the way my vector looks at all. For example, if I have a brush, if I have my brush and I have a 3x3 and I have a diagonal line going through it, if I expand that to a 6x6, when I do that, I end up expanding those pixels apart from one another. So I know that this one is purple, and I know that this one's purple. I know that this one's purple because I just expanded it. But what do I do? Because I used to have this many and now I have this many and I don't know what to do if I'm on computer. What the computer does is the computer is just going to make this happen. It's going to overlay the same amount of information and try to replicate it as much as possible. Now you have some smart engines that will actually try and make some of them 50% to smooth out the line and do whatever it can to make it look the way it was originally. But essentially you're still talking about squares in space. If you have a vector image, however, what will happen is as you cleaning up some stuff. If you have a vector image, as you draw an image, you tell it, I want you to go from this point to this point, and I want you to draw a straight line. And when you tell it that, I want to go from this point to this point, and I want it to be a straight line, and that line expands, it doesn't matter. It will draw the same line in the same way. That does mean that your line might appear to get smaller, because if your piece of paper is this big, and you drew a line that was this big, and then I blew this piece of paper up to this size, the two dots will still be in the same place, but the line will not be that thick. It's not going to grow in proportion. It's still going to be the same point size or pixel size. It's just that pixels, the amount of pixels are going to grow, which means that those 2 points stay proportionately in the same place, and the thickness of those two lines, because I didn't change my brush size, is actually the same. This one just looks thinner because the whole piece of paper is bigger. So that's a nice little optical illusion for you. Also, the pressure may have been lighter on the pen, which changes that a little bit, but that's not my point. So the difference between a rasterized image and a vector image means you can keep changing it, and a rasterized image means that you have committed to it being changed, to something that's already happened. So when you go to resize an image and your transform tool asks, are you ready to commit? It's asking because you're probably changing something to a different size. And if you do, it's not reversible. It's actually going to throw information away, especially if you're moving from larger to smaller. If you move from larger to smaller and you compress that grid, you're losing information. Your pixels don't change size. They're always the same size, which means when there are less of them, you actually have to go ahead and delete pixels in order to get it to be smaller. Those deleted pictures can't come back. The computer can't afford to remember them and continue remembering them the entire time until you decide whether or not you want to keep it. It's asking you to commit because it can't keep that information. That's why when you delete something, it's gone. So if you look at this text and we zoom in very close to it, you're going to see it has perfectly crisp edges, unlike the rasterized text, which does not have perfectly crisp edges. Remember, we looked at that way down here, and it has very odd edges. And the reason these two things have different edges is because the text is a vector and this other text is rasterized. I actually just transformed this text, and when it asked me if I wanted to commit to rasterizing the image, I said I did, and now it's rasterized. So you want to be careful when you say that you want to commit to rasterizing an image, especially when it's text. You probably want to keep that as editable as possible for as long as possible, as we talked about in the text video. But at the same time, your entire image is eventually going to be a raster image. And a single pixel on the surface can only understand so much information. It can only be color at a time, which is why it's important to utilize different layers. Because if you want something to be a little bit black and a little bit blue, you can't have them be both at once. You either have to pick that medium color. You could mix that medium color by blending them together, which again is just a complicated engine in your computer interpreting your input to a different rasterized result. Or you can take your top layer and lower the opacity, and now you're seeing a black pixel through a blue pixel, and that changes the color of the pixel that is seen on top. If you were to save this as a JPEG, it will become a fully rasterized image and all of these layers are condensed, which means you should always save your file as a painter file or a RIF file in order to maintain your editability in all your layers. Let me know if you have any questions, and that is all for today's lecture.